Subject name compiler design for the students, third year CSBS, 5th semester, unit 3. So this is a topic, memory allocation. So memory allocation is a form of routine which finds a block of unused memory of the requested size, and the memory allocation, its marking on the block will prevent it from being passed as a parameter more than once. Another routine is used to return the block to the system and mark it as not in use. So it will shows that whether the memory allocated or not. Memory segments. When a program is executed, the operating system allocates the following three memory segments, that is code segment, stack segment, data segment or heap segment. So code segment is a source code, usually in a read-only format to avoid accidental editing. Stack segment. The stack is able to detect stack overflows and underflows. So data segment or heap segment, it's a single continuous stretch of memory location at the disk position of the source code. In the memory segments, runtime environment manages runtime memory requirements for the following entities. Code entity. This code entity does not change at runtime. Its memory requirements are known as a compile time. Next entity is a procedure. So this is a static, but they are called in random manner. Stack storage is used to manage procedure call and activations. Variables. So in this variable entity will work at the runtime only. So it will support to the heap memory allocation scheme and is managing for managing allocation and deallocation of memory for variables in runtime. There are three types of memory allocation: static allocation, stack allocation and heap allocation. Static allocation type. So this is a fixed memory location, so it does not change when the program executes. In the static allocation, the memory requirements and storage locations are well known in advance. So runtime support packages for memory allocation and deallocation is not required. In the stack allocation, procedure call and their activations are managed by means of stack memory allocation. So it will be working in last in first out method. And then stack is addressed by stack pointers which are manipulated by machine instructions. The next method is a heap allocation, which is dynamically allocating memory storage and claim it back when the variables are no more requested. And variables are allocated and deallocated only at the runtime only. Pictorial representation of memory allocation types given. Text memory and static memory is a fixed one. Stack memory and heap memory is a dynamic one. The text part of the code is allocated the fixed amount of memory. Stack and heap memory are arranged at the extremes of the total memory allocated to the program. Both shrink and grow against each other. Except statically allocated memory area, both stack and heap memory can grow and shrink dynamically and unexpectedly. Therefore, they cannot be provided with a fixed amount of memory in the system. Thank you.